Hello everyone, thank you all for coming. So this is about a 60-minute talk. I'm gonna do it in 15 minutes, so hold on to your seats, it's gonna be awesome. So my name is Yoeri Staal, I'm from Staal Media, a virtual game company. We work with people all over the world. I specialize in artificial intelligence. You can find me on the social media here. So first of all, a little bit about AI. AI you can see as a mix of two things, computer science on one side and psychology on the other side. It's about understanding humans and then making computers function in a similar way. Now, you can make a perfect AI, for example, a chess bot that will always beat you, but that's not what I'm going to talk about today. I'm going to talk about enjoyable AI, which is an AI that doesn't kill you on every shot, but only a certain amount of shots. Now, how are we going to do that? First, I want to talk about the difference between individuals and groups. There's a big difference between making one AI and making a whole group of AI function. And then there's the static versus dynamic. Static is a character that's always the same. Dynamic is a character that either changes over time or is different during a fight. So, the static individual. So it's one person who is always the same. Now, this is in television, this would be the villain of the week. For example, in Scooby-Doo, every episode focuses on one character. Character is different every time, but it's always one character with a very one-dimensional personality. The game equivalent of that would be a boss battle. This boss is usually the checkpoint of a certain world to test if you learned a certain skill. For example, if you learned how to fly in the past world, this enemy is going to fly and is going to test your skill there. AI is all about decision making in games. The decision is made between all possible moves. For example, in Pokemon, Pokemon can choose between any of the 4 moves. Now the question is, which move are you going to take? Now the first way I would build an AI is build a random one. So it picks a random one out of all the possible moves. However, it's very important to always make a legal move. So for example, if you're making a first-person shooter, don't have enemies run straight through walls or something like that. Wait, already? Yeah. So in the first option, I said there's 4 attacks and you can pick a random one. But what if you skew the statistics a little bit? What if you take one action more often than another one? In the example on the left, there's a 50-50 chance between attacking and defending. And there's a very small chance of healing in the middle. But what if you use a vector that enhances the attack values and decreases the defense values? Now suddenly you get a very aggressive character. And if you put this in the right place in a game, suddenly this changes the whole dynamic. So that was the whole random thing. And if anyone here has seen Westworld, you know that it's all about memory and knowledge. So, for example, with a chess bot, you would have to feed it all the knowledge of previous chess games, and then it's going to make a decision thinking what was a good decision to make in the past, even if it's just a statistical one. Oh, and one more thing to notice here is that all the information is open, which means that the chessbot has 100% knowledge of everything that's going on in the game, which is a big difference with, for example, a poker bot where it cannot see your cards. So the dynamic individual is a character that changes over time or every time you meet him. The television equivalent would, for example, be a Vegeta that goes from a crazy supervillain to a more nice guy to back to a crazy supervillain again. The equivalent in a game would be a recurring boss. For example, Seymour in Final Fantasy. Every time you see him, he grows stronger and has a different moveset that you need to learn again. And in Magic, they found a really nice way to show two different versions of the same character on one card by flipping it over. So you have Evacyn, the protector, on one side, and then when something happens, she flips to the other side, and then she becomes this crazy character with totally different stats, way more aggressive. Yeah, so this is where I was going to mention the PokerBot. Again, this PokerBot is going to choose based on statistics what it's going to do, what happened in the past, that was a good move, statistically speaking. But you can create a different personality in a poker bot. For example, make a more aggressive one, or one that is so-called tilting, one that's going crazy. And depending on the situation, it can be better or worse. One thing I really like to do in my games is create a character that mimics the human player. So what it does, it analyzes how often you make a certain move, how strong that attack was, and then it mimics that number. So it really feels like you're playing against yourself. Now the thing is, this only works when the enemy has exactly the same skills or the same powers as you, which is why I chose this picture, because, you know, Power Ranger versus a Power Ranger. A homogeneous group is a group of enemies that are all exactly the same. For example, the stormtroopers in Star Wars. They just follow orders, you can kill them, you don't really care about them, there's always more coming at you, there's no real personal connection. The equivalent in a game would be, for example, the Heartless in Kingdom Hearts. There's always more of them coming, and you know exactly what you're fighting against because you've already seen a lot of these before. Now if we go back to these statistics and making a certain decision, if every character makes this decision on its own, then suddenly it's no longer, for example, an 80% chance of your enemy attacking you, but it's 80% of the whole group attacking you. All of them are making their individual decisions. And because of that, it looks as if the enemy actually has a strategy, where a couple of them are coming at you, while a couple are also holding back. Now, for example, a surrounding mechanic that I used in one of my games, it's literally one line of code. It says, come closer to the player. Unless you're too close, then go further away. Now, the beautiful thing about this, one line of code, and they will automatically surround you. You have a question? I'll save that to the end. A more elaborate version of this would be the bloodthirst mechanic, where there's a very small chance of a character attacking you. They're usually minding their own business. However, as soon as you start bleeding, as soon as you're hurt, then the chances of attacking you become 90%. Now, if you would put this in a game, again, 1 or 2 lines of code, you have all the enemies surrounding you, walking around, minding their own business, until one of them hits you, and then suddenly they're all coming after you. This would work really well in a horror game, for example. Ant colony optimization is one thing that is very important in artificial intelligence. You learn it somewhere at the start. And ants are just minding their own business. They're going in different directions looking for food. But as soon as one ant finds the food, it will drop pheromones. So other ants can smell it and know that food is nearby. So the next ant that comes nearby smells it and has a higher chance of going into that certain direction. Now, if he also finds the food, he also drops the pheromones, and the scent becomes stronger and stronger to the point where all the ants are going straight for the food. And the better the route is, the more ants are going to come there. So they will always find the shortest path to the food and the nest. Now, when you're coding a large group of AI, you can do this in 2 ways. Either as a hive mind, where one processor is steering all of the AI at the same time, or you can create them as autonomous agents that each make their own decisions, completely disconnected from everyone else. Now, the important thing is that even though all of these ants will be independent and minding their own business, you can still run this process on a single processor. Then you have a heterogeneous group where all the characters are different or have different statistics. And then the question is, how do you code that? For example, in Lord of the Rings, where you have a class-based system where all characters have their own class. And whatever an archer is doing is very different from what the tank is doing. And that is, of course, in an RPG very important. You don't want to have an archer that runs straight into battle all the time. Now again, you can use this, this chance-based system, but this time base it on what class you have. So a tank would be much more attacking, whereas a sniper would be running away more often, and the healer would be healing all the time. One thing I really want to use in one of my upcoming games is the idea of a commander. You pick a random character in the group, and whatever this character decides to do changes all the other odds by something like 80%. So suddenly you have the group moving as a group, but it's actually one very secret person somewhere in the group making all the decisions. And maybe this person doesn't even know that they're the commander. Neural networks, do I have the time for this? All right, neural networks in 1 minute. So to create a neural network, you put, there we are. You put inputs on the left side, you put numbers in there. Each of these numbers is multiplied by a vector, and one or more numbers are going to come out on the other side. Now the beautiful thing about this is that it doesn't really matter what you're calculating, as long as you can somehow put whatever world knowledge you have into the vector at the start. And then you test what is coming out, how well that is performing, and if it doesn't perform very well, you just keep on trying until it does better and better. That's pretty much what I just said. And the final thing is, this whole thing was about enemy AI and villains, but if you want to create a teammate, it's also pretty simple. You, instead of that character attacking you, you make that character attack whoever is your enemy as well. So the conclusions. This was pretty fast. Choose if you're going to have a single enemy, like a one boss to fight against, or a whole group of enemies, and also change their behavior depending on either the situation or whatever kind of character or class they have. And that's it. Questions?